listeners, this is Pushkala, and we have been seeing exploratory data analysis part 1 already. And we have been seeing some libraries that we can use to do data analysis in Python. So, the first two libraries we have seen is SweetWiz and AutoWiz. So, SweetWiz is basically a univariate analysis library, and AutoWiz is somewhere you can go with multiple libraries like you can visualize dist plot, violin plot, scatter plot, and so many other things. And it will even give you a snippet of what is wrong with the data set and where is the how variation and what is it you get with the outliers and everything. So this is basically the first two libraries we have seen. So I'm going to start with my third library. So the third library is Y data profiling. From Y data profiling. So if you want to install this library, just do pip install Y data profiling. That's it. So I'm just going to import this profile report from Y data profiling. So this is the library. I have imported the library. So what I'm going to do is the line code is as simple as the SweetWiz. I'm just going to do profile report of DF. And I'm going to export this into a file, HTML file like the others. So the report can be saved for later reference. File. So I'm going to say just profile report.html. Profile report, I'll say iris. Profile report of iris.html. So the data set is being taken and a lot of other analysis is happening right now, and let it roll for a while. So as it says here, you can see actually what is happening. It is creating a scatter plot and it is creating whatever diagram so far. It is being displayed on the side for your reference. So my file is exported. When it completes, just go to your file source. Here it is. This is my folder, and you can search here for the PR iris. So this is my HTML data that is being exported. So now I see an overview of my data sets, how many variables are in my data set, and that is how many columns, and how many observations is nothing but how many rows I have in my data set, and I have no missing cells and no missing percentage. And I have one duplicate row here, and the percentage of duplicate rows is 0.7, and the total memory size and record size has been mentioned. So in here, the number of numerical type and the categorical type is also displayed. So we have this Setosa versicolor virginica column, species column, which is the only categorical column here. So that is being segregated as well. So this is the alerts that I'm getting. So what is this alerts is? How, to which column is highly correlated? That is what we are getting from here. What is the high correlation that is being available in the data set? So species is uniformly distributed. That is all the Setosa versicolor and virginica has equal number of rows distributed on them. And you have one duplicate column and you have 4 high correlations in your data set. So these are the analysis that is being given. Let me go for reproduction, where your analysis started in duration and how much time it took and all it is referred here. And we'll go to the next session. So this is a histogram plot where you can see all the, it has high correlation is present here in this particular column, and you are seeing the histogram. And again, all the maximum, minimum, missing values, distinct values are all present. Same for all the univariate columns. And as you can see, this is the uniform this was talking about. In alerts, it said species is uniformly distributed. This is what it means. Uniformly distributed means all the categories has equal number of values. So we have seen that, and this is the interactions where you can switch between the data set. So it is in petal length and petal width mode, and it is giving out all the possible graphs. So what we can do is we can switch petal length and petal width. What all the graphs I can get, and petal length to sepal length, and the other things. So sepal width to petal length, I'm getting these kind of uh, maps. So all the interactive maps you can see here, and I think one is merged with another. So you can refresh this and see for yourself. And this is a correlation map. Where is this high correlation? Dark blue is where you can see the high correlation. And all this diagonals is actually the same thing. So when you see the first one, it is sepal length and sepal width. The second part is sepal width and sepal width. So ignore all the diagonal columns and see the rest. So wherever you see the dark blue color, that is where high correlation is exhibiting. So this is a dark blue where this is sepal length and petal length. We see high correlation there. So most of the data set occurs in high correlation. Only the feature that is not highly correlated is sepal length and sepal width. Other than that, most of the things are correlated. So here, I think my laptop is not working fine or something, but this will not look like this. You can see a better graph over here. I'll just refresh the page. Still showing me like this, but usually you will not get jumbled columns like this. Okay, so the first one is histogram, and the second bunch is box plot, and the third bunch is QQ plot. QQ plot is where you can confirm whether the data set has a normal distribution and whether the data set is skewed or not. So if the blue dots is our data points, and if it is correctly lined with the red dots, these are normal distribution. So here, let's see in the third one, sepal length, I guess. So sepal length is normally correlated, other than, normally distributed. So the red line and blue line is correctly merged. That is what we get from this. And the samples, say the first row and last row is when you work with pandas library, you will say head of 10 and tail of 10. That is what this is. It will display the first 10 rows, and last rows will display last 10 rows from the data set. And which is the missing, duplicate rows? That is this one. In Virginica, you have a duplicate where this particular row has been repeated twice. So this is profile report. So we are done with the third library. Let's go for the fourth one. So the fourth one is detail. So you can install this by using pip install detail. That's all. It doesn't require any big of an implementation here. Run that. Okay. I'll just comment this. And detail. Let's go with detail. Detail.show df comma ignore duplicates. It is already satisfied. Okay, then no problem. So this is the uh, code that you need for EDA, just one line of code. So let it load. Okay. So apart from the other libraries, all you're seeing is a bunch of uh, data set. All you're seeing here is a data set, 5 columns and 150 rows. You see here is all data sets. So what is so special about this detail? Just hover over this. You can, when you click on this, you can see new tab. Just click on the new tab so it will be easier for you to see what all is in here. So as you can see here, when I hover over this, there is a new menu option that is displayed. When I go to visualize, I have so many analysis here. I can go for display, duplicate analysis, correlation analysis, missing analysis, even predictive curves for time series analysis, charts and network viewers, so other things. And in highlights, you will have heat map and so many other things. And in actions, you can do all the pre-processing and summarization work. So let's go with visualization first. Describe. So as you can see here, this is a little bit more advanced than the other libraries we have seen so far. So it has displayed all the necessary things you need to know about first column, that is sepal length, and it is giving you a box plot. So if you want to see a histogram, you can just switch to histogram. And if you want to see categories, you can switch to categories. And if you want to switch to QQ plot, where you will find out how much proper normally distributed the data is, you can see it here. And you can click on this outliers and you can see whether the outliers is present in here or not. So there is no outliers in this column. So you can switch to sepal width and look at outliers. There is 4 outliers present. So this is a very easy library to analyze most of the charts. So let me go to the previous tab and again to the visualize. Let's go for charts. So here you have a huge bunch of charts you can work with. So let's go with scatter. So you will have to choose which of the uh, variables you want. I have chosen sepal length for X and petal length for Y. And for the group, I have to choose, let's go with species. So the colors will be different. So this is the scatter plot. You can go with scatter plot and I can even go with 3D scatter. In 3D scatter, in 3D scatter, I'm going with the same X is sepal length and Y is sepal width. And let's go with the Z axis petal length. So the chart is loading. And you can see here, I have gone for a 3D plot. This is smaller in size. Let me see, I can fan this. Okay, that is not possible. Even though it is smaller, you can see what is happening in there. You can rotate up to wherever you want. You can zoom it into whatever procedure you want. You can see the variations inside the graph. You can change the color scale here. Even if you want to do a pie chart, that is possible. This is the pie chart for whatever the variables that I have already selected. So you can do all kinds of charts here. So this is detail. So with these 4 libraries we have seen so far. So first we have seen SweetWiz, again the AutoWiz, and the third one is wide data profiling, and the fourth is detail. So with all these libraries, you can usually reduce the work what you do on data analysis and exploratory data analysis, and you will be able to focus on extracting insights from the data. That is all you have to do instead of coding for a long time. So I hope this is a good alternative for you guys who might not love coding so much. So thank you. And if you have any doubts, leave on the comment section, and bye bye.